Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to talk about pneumatic cylinders. So let's dive right into it. Well, last episode we talked about motors. So this episode we have to understand why we use pneumatic system. Yes, P is silent, don't ask me why. Now, pneumatic simply means one thing, it's air powered. Now you have to understand this. When industrial revolution began, the first thing we used after steam was compressed air. Basically, if you go to any machine shop, any basically thing that deals with heavy machinery, you will easily find quote unquote machine shop compressor and all that, and lot of air tools. So we are familiar with the idea of using compressed air to do work. Heck, in the height of 1900s, people used to make a literal train running on compressed air, because if some places there were explosive gas and all that, like inside mine shaft and all that, so they were generally using compressed air. Now it's replaced by electric system, but you can understand, like, compressed air has like a very long history. We know how to use it, and it is very simple. Now, benefit of that it is very simple, it is also very cheap comparatively speaking. Now, in terms of power output, basically how much power you can get, it's more than powerful enough. Basically, if you want to directly compare it to against let's say the most powerful hydraulic system versus the most powerful motor based system, again those will win, but this is more than enough. Basically, if you want to do anything, it is more than good enough. You will never have a situation where you're like, hey, because it's an air system, it's not powerful enough. You won't have that. And in terms of precision, like how repeatable it is, in terms of like how reliably you can make a routine adjustments and all that, it is precise enough. It's not gonna be used in a surgery robot, but it is more than good enough that it is reliably and regularly used in almost a lot of medical industry, specifically the machines that deal with drugs. Basically, they have to make drugs, so they generally utilize this system. So the first aspect of using air power into taking air power into mechanical power, we employ pneumatic cylinders. Now these are the most simple and the most powerful system out there. You have to understand it in this way. Can you get more power out of a motor system? Yes, but it will be more expensive, more heavier, and it simply won't be as cheap. And can you get even more power out of a hydraulic system? Undeniably so, but this is simple, cheap, and effective, and it is very easy to use. To give you a context of this, in India, in many metropolitan cities, we have Volvo bus or even normal bus. They have pneumatic system as their gate mechanism, because pneumatic system can be set in such a way that you have only two commands: open or close. Now, what does open means? Open simply means this rod is fully extracted. Close simply means the rod is fully closed. That's it. There is nothing else. Like, you can literally make a system where this full motion opens the door, full motion closes the system. So benefit of that, you will literally have no microcontroller and nothing, just a simple switch turn on. Again, you have to have something that can detect let's say air pressure in the compressor tank, so you can be like, yeah, at least it periodically it will compensate for leaks periodically, like how much you are using, so it will maintain that. But other than that, you don't need anything fancy. Like, people have entire printing press running on this sort of system where they have not even a single microcontroller. Now again, many of them have been retrofitted for microcontroller for better precision and control, but you can understand this. Like, it is that simple and that powerful that you can build an entire manufacturing system without ever touching a microcontroller, and it is cheap. Like, in terms of power to cost ratio, this is king. Like, let's say you want something that pushes 100 kilogram, let's say 10 centimeter, that is your requirement. 100 kilogram for 10 centimeter motion you want. The motor system would be like, let's say $500. Hydraulic system will be $600. This puppy will be $30. Like, again, that's the exaggerated idea, but you have to understand this. Like, these are relatively cheap system. So that is why, like, almost everywhere you think about pneumatics, you will find these. Then again, that's generally used for big bulky machines where you have absolute motions, where you're like, okay, move full, open or close. What if you want something more precise, more control, in a robotic arm, we generally use what we call rotary actuator. Now, rotary actuator is generally used for wherever you need rotation rather than literal motion, but it is much more complex and expensive than linear systems. Linear systems are very cheap. This, on the other hand, is very complex. Now, how does this work? Is very simple, relatively speaking. You have a chamber is divided by the valve. That is why it's generally classified vane or rotor. Now, this vane, it rotates. Like, you want basically it to rotate counterclockwise, you will put high pressure in this section. it will push it up. You want to rotate clockwise, you will put high pressure here and it will move it this way. It is very simple. I have provided the video down below where you can see the whole animation. There is nothing fancy about it. It's like you push air in, so rotate it this way, push air in to rotate it that way. And it is very well suited for robotics, and many of this sort of motors are used where you have to spin something like this again and again. Now again you might be like, can't we use motors? Yes, but again, cost. When you are thinking about like a motor system that can do something like this does, it will cost more. Relatively it will cost more, so generally people use this. That is why it is so popular. And there are scenarios where you can easily guess, like this does not allow you much range of motion. You can barely go to 350 degree, you cannot go 360. So what they do, generally have a gearing system, either a planetary gear system or a linear gear system, where they can easily get more rotation if needed. So these are rotary actuator, and in terms of robotic arm, they are almost necessary. You can't have a very complex robotics arm using the linear system. Using this, you can get a very precise robotic arm. I have provided the video down below. Okay, so pneumatic system have been used for like almost a century. Are there any new development in the field? Well, recently, as in like 20 years ago, somebody came up with the idea of pneumatic muscles. Again, pseudo muscles have been tried, but this time it was standardized, mass manufactured, and people started to use in robotics and other systems. So muscles literally work in the same way our muscle works, because our muscle has only one action, it contracts. So whenever you get dual motion, like let's say you are pulling up your hand, but how do you drop your hand? Again, gravity is helping you, but you have to understand there is another muscle here that is doing the contraction. So you always get dual axis motion. Here is the same thing. If you want, like let's say you want a robotic arm that does this, you have to only use one. But here's how the heck it will fall again. Again, gravity can help you, but if you don't want to rely on gravity, or you want to use it in space, you can simply have a second motion that does this. So all it is just a basically balloon with non-stretchy material. It cannot stretch. That's the whole idea. So it is like a pipe. When you put pressurized air in, it expands like a balloon. So it shrinks. So the distance, basically the length shrinks. So you will have a, let's say, cylinder or something like this, where it will be like, okay, unpressurized, it is like 10 centimeter long. Pressurized, it's 5 centimeter. So you will get that motion. And these are very powerful. You can these sort of motors can easily pull upwards of 20 kilograms, and you can build it in your home if you want to. So these are also very famous, specifically with the robots that are meant for human compliances, because you have to understand this. Hydraulics are so strong, so powerful, that they will not think about even a second before it goes through a human. Like let's say you have a robotic arm which is running on hydraulics, and there is a person, then that person is gone. Now this has enough give. It can be strong, but it has enough give that you can have enough time to react, detect, and disable the robot. So if you want to make a pneumatic system which is like human safe, inherent nature, the fuzzy nature of the basically pneumatic systems will allow you to do that. And then there is this pneumatic trunk system, where you can see it looks like a Dr. Octopus, but it's not based on Dr. Octopus system. It's more based on elephant's trunk. So it is, as you can see, the human is nearby, and this is primarily focused on basically making farming robots, because this is very delicate. The benefit of that, you can think like, hey, that means it cannot do very heavy work. That is true. It's not meant for that. It is meant for doing a very delicate task. Basically, let's say you want to do take care of a plant and all that. You can't have like hydraulic system going in, because any wrong motion, it will end up killing and destroying everything else. So this sort of system is used. It's quite intricate, and I have provided a link down below. You can buy it, again, provided you have deep enough pockets. So in future we can easily expect to see these two systems used more and more. Okay, if hydraulic pneumatic systems have been this kind of cheap, affordable, powerful enough, precise enough, then why the heck we don't see it everywhere? Well, it does have certain problems. Obviously, same way motor has a problem of cost, this also has certain problems. Problem number one, it is noisy as hell. Like anybody who's living in India, they will know this drilling operation that we do for water well, and this is noisy as hell, because it's running on basically compressed air. Because whenever you have compressed air, that you can be having like around 100 psi or 200 psi, when you vent it, by default there is a giant pressure gradient, where you go from 200 psi to 15 psi of atmosphere. That by definition causes shockwave. By definition, like it is an explosion. So it is noisy as hell. Even the robots that have like baffles, air return channel, like with like suppressor, muffles, and all that, is still noisy as hell. Like in some like if your end goal is making a robot that is 100% silent, let's say you want to make a robot for, let's say, nursing home, where you have to make sure that people like children are sleeping absolutely quietly without undisturbed, you cannot utilize this. It's like it will keep doing that. And I have provided the link down below where there is a human command. It's quite it's very quiet, but it's nowhere near as quiet as an electric motor system can go. Then there is the fudge factor, because it is precise enough but not very precise in terms of linear. Basically most linear systems are like just on or off. Now you can find one where you have a system of feedback and all that, where you can like control it to some extent, but you can never control it to the same extent as you can control the hydraulics, or you can control the motor based systems. So by definition it's not suited for, let's say, you want to build a robot that does welding, and you want to like weld two thin panels of aluminum or steel, and it has to be very precise, like 1 millimeter precision. Forget about it, you cannot do that, because air by definition is compressible. So by definition you cannot define it like, hey, I said I'm sending 5 liters of air. Again, by the time it goes into the cylinder, let's say for some reason the load is high, the 5 liter will become 4.9 liter, because it will compress. That is why we have air compressors. So that inherently gives it a fudge factor. By default it will always have fudge factor. Now you can drive it, you can overcompensate it, but that makes it even worse. So rather than like okay, not meeting it, it might be like directly drive into it. So that fudge factor flat out removes it from heavy applications where you have to have let's say hundreds of robots doing precision welding work. And on top of that, let's say you want to do some normal things where you don't have the need for absolute precision. It is a piping mess. Like wiring, you may think like if you see a robot and wiring system is like, dude, it's complex. Absolutely so. But the moment you look into this pneumatic systems, you'll be like, are you seriously kidding me? Like this is on a different level. The complexity of these puppies are on a different level. So all these three things combined does not make a pneumatic systems like used for all scenarios. It has its advantages. Let's say like you are running a bus and you simply want door open and close. Okay, best system out there. You want to do like some simple valve control, best system out there. You want to make a precision robot, hell no. Like again, you want to drill onto the earth, utilize this as much as you want. So there are some pros and cons, same as with any system. So this was my presentation on pneumatic systems. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.